trigonometric expressions using a sum and difference identity. So these, I have a little song. I just kind of sing it. No. Do you hate them? Your face says yes, you do. No, I just kind of sing it for myself, and it helps me remember. You can do it or not. You know, it's up to y'all. You can do what you want to do. So if it'll help you, though, I would recommend doing it. Then we'll practice solving problems of different types just to see how we apply these, okay? Well, I'm getting ready to show you. Okay, so these are both called sum and difference identities. Sum means addition, difference means subtraction. But anytime you see sign of something plus something else, so an angle alpha plus beta, it's just sine, cosine, cosine, sine. That's the little song. So sine is what you're starting with. See that? See that you have sine of the angle plus the angle? It's just sine, cosine, cosine, sine. That's all I do in my brain. I just think sine, cosine, cosine, sine. And then you keep the same sign. So what I mean by that is if you start with a plus, you're going to keep the same. This is not going to work today, y'all. Where I broke the end off this Apple Pencil. It's not really working. I'm going to keep trying, though. We'll see. Okay, so you keep the same sign. So, again, it's sine. Oh, no. It's not even sensing it now, team. Oh, there we go. Sine, cosine, cosine, sine. Okay? And you keep the same sign. Okay? And then you just plug in. So I just sing that little chant, and then whatever's written first, you write it first with the two pieces. Whatever's written second, you write it second. And I'll show you how to do that in just a second, okay? So sine, cosine, cosine, sine, and keep the same sign, all right? If you start with cosine, it's cosine, cosine, sine, sine. Cosine, cosine, sine, sine. And you will notice if you start with a plus, it actually changes. So that's how I keep up with these. See how that's a C and that's a C? You change the sign. So sine, cosine, cosine, sine, cosine, cosine, sine, sine. All right? And that's it. And again, whatever's written first. Come on, you can do it. It doesn't want to do it, y'all. Whatever's written first, you put that first. And whatever's written second, you put that second. Okay? That's it. So let's apply this now. So use the sum and or identity difference formulas to verify. So we have sine of t plus 3 pi over 2 equals negative cosine of t. You know what's beautiful about these is I'm showing you what it has to equal. You just have to get there. Okay? So what are you starting with? Sine or cosine? Sine. So we're going to write sine, cosine, cosine, sine. Sine, cosine, cosine, sine. Sine, cosine, cosine, sine. Sine, cosine, cosine, sine. Can you say it that fast? Try it. Good job. You did it. Good job. Okay. And then whatever's written first, that's what I said. So whatever's written first, we're going to write it first. Oh, no. The end just fell off. That's a bad day. Oh, can I? All right, y'all. Go ahead and plug in that T while I'm trying to fix this. Yes, thank you. And whatever's written second, we're going to write second. Okay, so we'll have T here and here. And then we'll have 3 pi over 2 here and here. And we're trying to show that it equals negative cosine of t. Okay? All right. So remember, sine, keep the same. Sine, keep the same. So I'm going to put a plus right there. So because it's sine, we're going to keep the same sign. All right? So if you notice, this says sine of t and then cosine of 3 pi over 2. Can you tell me what the cosine of 3 pi over 2 is? Yes, you better, right? You better know how to, right? So this is 0. If you go all the way around, that's 2 pi. Half of 2 pi is pi. Half of pi is pi over 2. So we have 1 pi over 2. When you go here, 1 pi over 2, 2 pi over 2. So this is 3 pi over 2, which means this would be 4 pi over 2, and that's why it reduces to 2 pi over 2. 2 pi. Okay? So what are your coordinates at 3 pi over 2? 0, negative 1. And we know the x is cosine, the y is sine, right? So I'm going to plug in 0 right here for that cosine. Okay? So sine of t times 0. And then plus cosine of t times, what am I going to plug in for sine of 3 pi over 2? I'm going to plug in negative 1. Thank you. And we're trying to verify that it equals negative cosine of t. So 0 times sine is just 0. And then negative 1 times cosine of t is negative cosine of t. And 0 minus cosine of t is just negative cosine of t. Then that's it. May God bless you. You're welcome. So sine, cosine, cosine, sine. Okay? It's not really a song. It's more like a little chant. Questions on that? Anybody? No? All right. So you'll notice this one I'm going to help you with. We're starting with cosine. So this one is cosine, cosine, sine, sine. Cosine, cosine, sine, sine. Cosine, cosine, sine, sine. Okay? And then we're going to plug in whatever's written first. We're going to plug that in first. Whatever's written second, we're going to plug that in second. Okay? And then we're going to do what with the sign? So because it's a C, we're going to change it. Good. So because that's a minus, I'm going to actually put a plus. Okay? And then I've had students try to put a negative t. You just put what it is. That minus tells you to change it to a plus, okay? So this is going to be 3 pi over 2. This is going to be 3 pi over 2. And that's t and t, okay? And we're trying to verify that it equals negative sine of t. All right? I was trying to make it bigger. How do I make it bigger, y'all? For some reason, when I taped the end on, it got really skinny. Do you see that? Can everybody see it? I'll leave it alone if you can see it. You can see it, everybody?
You can probably change the thickness of the marker.
Ooh, there it is. Thank you. Okay, so cosine of 3 pi over 2. 3 pi over 2 is right here, right? That's the point 0, negative 1, yeah? So we're going to change cosine of 3 pi over 2 to what? 0. 0 times the cosine of t plus the sine of 3 pi over 2. Negative 1 times the sine of t. And I want to see, does it equal negative sine of t? These are called trig identities. When you're trying to prove that actually equals that, okay? It's a trig identity. You're showing that it proves it equals something. Okay, 0 times cosine of t will be 0. And negative 1 times sine of t is negative sine of t. 0 minus sine of t is just negative sine of t. So we verified that they are in fact equal. Okay? Questions? You like them? Okay, so if you start with sine, what should you sing? Sine, cosine, cosine, sine. And then whatever's in the parentheses, if it's listed first, just put it first in both pieces. If it's listed second, okay? And then if it's cosine, 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 sine, sine. All right. It's fun, right? Okay. Go ahead and see if you can prove this one for me, and then we'll go over it. All right? All right, person 12. Is that you? Okay. Do you mind telling me how you started it, please, sir? Sine, cosine. Cosine, sine. Okay. You put the x first. I'm doing it in pieces. I'll put it. Then you put pi. Okay. And then you said you put minus. Why? Because sine is the same. Good. You got to keep it the same, okay? Whatever sign it is, you keep it the same. All right? And then what'd you do? For cosine of pi, you put -1, okay? And for sine of pi, you put 0, okay? Y'all agree with him? Okay, good. And then? Good. Mm-hmm. Cosine times 0 is just 0. So did you prove it? Do you like those? I like it because you see what you're supposed to get. So if you don't get that, you can go, okay, wait, what happened? Right? With a lot of them, you don't have the final answer. So you're kind of you're just trying to figure it out, right? But for these, you have what the answer is. You just got to get there. All right? Good job. And that's because pi is right here, right? Which has a point of -1, 0. Good. Very nice. Good job, sir. Any questions on this? Okay. So I have another one. Another one that's 2 parts, okay? I'm going to let you try it, but I'm going to remind you, anytime you have things that follow a minus, you should put them in parentheses. Good. So that's your hint. Anytime you're replacing and you have things that follow a minus and you replace it, you need to put it in parentheses, okay? Sure. Thank you for asking. Sure. You're welcome. Thank you for asking. All right, turn and talk about it. All right, person 16, please.
Oh, I see. But, like, I kind of got it way.
That's okay. Just do what you can.
So, like, for the sun, for instance, I just kind of like the sin, cos, sin.
Yes, sine, cosine, cosine, sine. Okay.
And then I put x and y plus xy.
And then y. So whatever's listed first, you put first.
Yeah.
Okay.
And then I put that around parentheses. And then after that, I put the like, minus and then the same.
Okay.
Same thing,
Okay. One more question. What'd you put for the in between them?
I was just like the minus.
Well, in between these two? No, if
Well, plus.
plus, yes.
That's
Okay.
why I just meant like.
And then over here, you're saying you put minus because it follows the minus. I got that. And then you put this in parentheses and you did sine. You said the same thing.
Like the same thing, just minus.
Just minus because you keep the same. Okay. Ooh, I was messing up. You see that? So sine, cosine, cosine, sine. All right, and we're trying to show that it equals 2 times the cosine of x times the sine of y. Let's see if that happens. Because on this one, you don't have anything you can replace. There's not a pi over 4 or a 3 pi over 2 or pi or 5 pi over 3. You don't have anything that you can actually replace, right? So we just have x's and y's. So if you look, you have sine of x, cosine of y, cosine of x, sine of y. So can you combine those? No, you cannot, right? Because you would need sine of x and sine of x on that second part. Cosine y, cosine y. So because they have different variables, you cannot combine them. They're not like terms, okay? So if you look at the next piece, can you combine those? Can you combine those? No, thank you. Again, not the same thing, right? So the only thing we have left that we can actually try to do is distribute the negative, right? Right? So we're going to have sine of x, cosine of y, plus cosine of x, sine of y, and then minus sine of x, cosine y, and then minus the negative is plus cosine x, sine y. Had you tried that? Had you got that far yet?
Yeah, I think I'm just following.
Oh, okay.
I just got to like that part.
And then you weren't sure what to do?
Oh yeah.
That's okay. Does that make sense why we can't do anything other than distribute? Okay. So now if you look, you have sine of x cosine of y. Do you see another sine of x cosine of y? Yeah. Right there, right? Okay. And it's following a minus, right? And then if you look here, you have a cosine x, a sine of y.
Oh, okay.
Okay. There it is.
Yeah, that's just what I thought.
That's okay. So what happens with the teal color, the sine x cosine y? They just cancel. And then you have cosine x sine y plus cosine x sine y, which is? Good. So did I verify? Okay, I have a question for you. What if it had been written this way? It's the same. Multiplication is commutative. It means you can move it, okay? So just make sure you're aware of that. Because sometimes people are like, oh, I couldn't prove it. I'm like, yeah, but you did. You did prove it. You can rewrite multiplication, okay? Any questions for me? No? All right, we're going to use those in just a second, so I need to make sure you're good with them. Because we have something called the double angle formula. All right, so we're going to use that. So if you see this, sometimes people have students memorize it. I don't actually memorize it because I've already got too much in my brain and we only have so much storage, right? I'm starting to lose some of you. You're going to sleep or you're like really leaning down and not tuned in. So wake up, stretch, do what you need to do if you need to stand up. Everybody, you got 37 more minutes, so I need you engaged. Come on. Do what you need to do. Take a second. Do it. Good job. There we go. Okay. So the double angle formula actually comes from what I just taught you. All right. You may not see it right now, and that's okay. But I don't memorize this formula because I can derive it really quickly. Okay. And usually I tell y'all, I show you the derivation, but I tell you, you don't need to worry about memorizing it. Right. Don't worry about it. So we derived the pi over 4 family, so you would see where square root of 2 over 2 came from. But did I make you ever do it again? No. But I wanted you to see it's not just arbitrary things that some mathematician made up. It comes from, it's grounded in logic and makes sense. So this one, the way I remember this, if you have sine of 2x, you can split 2x, and that's sine of quantity x plus x. Do you agree with that statement? Yes? Yeah. If it was x times x, that would be x squared. So because it's 2 times x, you have 2 x's, you can split it and put x plus x, right? And now you should see it. You have sine of something plus something. So sine, cosine, cosine, sine. Whatever's written first, we're going to write it first. So that's x times x, or x and x, right? But we also have x in the second position, so x and x. And then remember, if it's sine, you keep the same. Good. So I'm going to put a plus. Well, look, you have sine x, cosine x, cosine x, sine x. Do you notice anything? They're all x's. So can you combine those two things? Yeah, so the double angle formula is 2 cosine x, sine x. Or I could have written it 2 sine x, cosine x. It doesn't matter. All right, and that's it. So that's actually the double angle formula for sine of 2x. It's 2 cosine x, sine x. Okay? So let's derive the cosine of 2x, the double angle formula. So these are called double angle formulas. Let me highlight that. That's what these are called, okay? So if you've had trig before, they would have just shown you probably the formula, but I want you to see why it is the formula, okay? So what do you think we should write for cosine of 2x? Cosine of x plus x. And then what'd you say? Cosine, cosine, sine, sine. Okay? Whatever's written first, we're going to write it first. Whatever's written second, we'll write it second. And then because it's cosine, we're going to change the sign. Good. So we're actually going to put a minus. Good. Okay. What is cosine of x times cosine of x? Cosine of x squared. The other way to write that would have been cosine squared x. Yes? Okay. You're welcome to write it either way. I don't care. All right. And then minus sine of x squared. Good. And that is your formula. So the other way you might see it, I wrote it right there. Okay? Questions? That's called the what? Double angle. So the double angle formula for sine of 2x is 2 cosine x sine x. The double angle formula for cosine of 2x is the cosine of x squared minus the sine of x squared. Okay? Any questions? No? All right. Before I show you this one, I used to derive it, but then it got to where I was getting the blank stare of like, So, that one's not as beneficial for you. So you can trust me, I hope, by this point that it's just not math magic, that you can derive it. All right. But let's skip it for a second and go to this one. Are you okay with that? So we can practice some of this double angle stuff. Did you say no? My brain was like, did he say no?
I say yes.
You did not. That's okay. I'm going to power through. I'm going to help you. Okay. So if sine of t equals negative 8 over 17.
No, I'll let you do it.
Okay.
Or you do it like.
And then I'm telling you that pi. Ooh, that's not what I meant to do. Pi. I can't even talk now. You might as well ask me whatever you're going to ask me.
I was just gonna say that.
Sure. Go for it. Okay, so this is similar to the ones I've shown you before, right? You've seen this notation where I give you either sine, cosine, tangent, cosecant, secant, cotangent, right? So t is just the angle, okay? So this tells me where that angle is on the unit circle if it's in quadrant 1, 2, 3, or 4. And then I'm giving you sine is equal to negative 8 over 17. So what quadrant are we in if we're between pi and 3 pi over 2? 3. So I'm going to draw in the third, okay? And then the angle is always anchored at the origin. And then do we connect to the x-axis or the y-axis? X, always. That's why we talked about reference numbers, right? It's the shortest distance to the x-axis, okay? And then the angle is, like we just said, it's rooted at the origin. That's where it's anchored. The side across from the angle we call opposite. The side across from the 90 we call hypotenuse. So this last side we're going to call adjacent. Okay? So I'm not making you find all 6 trigonometric functions. We already did that. I tested you on that, right? And for the most part, everybody did really good with it. So good job. Okay? But instead, if I have a double angle, I need to figure out what I need from this, okay? So I gave you sine. So if you remember, so, ka, toa. If I gave you sine, you know which 2 sides. So, ka, okay, opposite over hypotenuse, right? So the opposite side is negative 8. The hypotenuse is 17. Would you agree with that? Did you go down on that opposite side? Yes, so it makes sense that it's negative. Okay, remember, if you go down or if you go left, you got to negate those sides. Okay? Is the hypotenuse ever negative? No. That's because Pythagorean theorem, right? You always have 2 sides squared adds up to equal that side. So it's always going to be positive, okay? All right, so the cosine of 2t is just cosine of t plus t. I get it that you could flip back in your notes and get the formula, but when you have a quiz or a test or a final exam, you're not going to be able to do that. So let's just derive it, okay? So it's cosine of t plus t. I can rewrite. And then it's cosine, sine, sine. They're both t's because even if I'm following that formula and I replace both of these, I'm still getting the same thing though, right? And then for cosine, you do what to the sign? Change it. So I'm going to put a minus. Okay? So we can simplify here, or you can plug in. That's up to you. Okay? So the cosine of angle t, I am going to rewrite it as cosine of t squared minus sine of t squared. Okay? Do you know what the sine of t is? Do you know what the sine of t is? It's negative 8 over 17. I gave you that, so we're going to square that, okay? But if you look, do you have cosine? Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. Do we know adjacent? No, which is why that previous section I taught you is so helpful, okay? So to find adjacent, we're going to have a squared plus b squared equals c squared. Really important that you put the hypotenuse as c, okay? Really important. So we're going to have 17 squared right here. Okay? And then, does it matter where you put the negative 8? No. Thank you for the head shake. I'm just going to put it as a. Okay? So negative 8 times negative 8? 64 plus b squared equals 17 times 17? It's what? 289. Sorry. Why are you doing it with your hands? Just for funsies? Okay. I was like, is there something happening? I let you have surgery and not known, so I'm double checking now. I'm going to do better, okay? All right. So we're going to subtract 64, right? And then we're going to have b squared equals 9 minus 4 is 5. 8 minus 6 is 2. 2 minus nothing is 2. So we get 225. So then we square root. B is either plus or minus 15. So this is called a Pythagorean triple because it works out perfectly. And is it positive or negative? Look at the direction you went. You went left, so it's negative 15, right? So now I can plug in cosine. Cosine is adjacent divided by hypotenuse. So negative 15 divided by 17. And now look, you have nothing but numbers now. Which is kind of amazing, right? So negative 15 times negative 15? 225. 17 times 17? 289. And then minus negative 8 times negative 8? 64. 17 times 17? 289. And the beautiful thing is you have a fraction minus a fraction, so you need a common denominator. And look, they both have the same hypotenuse, so we already have a common denominator. Okay? So when you're subtracting fractions, you don't change your denominator, and then you just subtract the numerator, right? So 225 minus 64. 5 minus 4 is 1. 2 minus 6 doesn't work. So we borrow from this, we'll make it a 1. This becomes a 12. 12 minus 6 is 6. 1 minus nothing is 1. And we get 161. Yes, or in my seat. Thank you. So 161 over 289. Questions for me? Pretty cool to see how you can apply that double angle formula, right? Any questions? No? Sure. Here's sine of 2t, okay? So we just did cosine of 2t. You're using that same triangle, so I'm going to leave this right here for you so that you can look up and not be having to flip back and forth if that's annoying. So there you go, okay?
Yes, sir.
Sure. All right, person 3. Who's number 3? Okay. Do you mind walking me through what you did, please, sir?
This is sine,
Okay. Sine, cosine, cosine, sine. Okay. Keep the same sign, which would be plus, because it's sine. Good. First term, second term. Okay. Mm-hmm. Good. Because they're like terms, because both angles are t, they are like terms, and you can put 2 sine t, cosine t. It's fine if you had put 2 cosine t, sine t. Doesn't matter. Okay? And then what'd you do? Sine of t is negative 8 over 17. Okay? Negative 15 over 17. Yes. Okay? So you did 2 times all of that? Or just negative 8 times 15?
just
You said this piece is what? 120? Oh, see, I misheard you. I thought you said 420. I was like, no way. Sorry about that. Okay. Uh-huh. Which is? 289. Good. Okay. And then 2 times 120? Okay. To get? 240. Y'all agree with him?
I do.
Any questions? Any questions? No? Okay. Let's see. Were there any more? Yeah.
Go back up real quick.
I refuse. I'll go back up. Just kidding with you. Hey, go ahead and try this one, everybody. Okay? Try this one. I'm trying to make sure you're good with double angles before I teach you half angles. So I'll come back to C and D. I will definitely come back to them. Let's make sure you're good, though, with double angles. Yes, please tell me. Yes. Are you okay? All right, who's number 9?
Me.
Okay, have you had a minute to try it?
Yeah.
All right. Walk me through what you did, please.
Okay, so, well, first thought I saw that it was between pi and 3 pi over 2, and so I drew it in the third quadrant.
Third quadrant, beautiful.
And then I connected that to the x-axis.
Yeah, good. Okay.
And, it gives you sine,
Mhm.
so the hypotenuse is 5, and then the opposite angle is -3.
Good.
And then, well, this one was simpler because the numbers were small, so like 5 squared is 25, so the other number up top would be -4.
Why does that have to be -4?
Because -3 squared is 9, and then 25 minus 1 is 16, and -4 squared is 16.
-4 squared is 16. Yes. So you did Pythagorean theorem without writing it because you did 5 squared minus 3
That's
squared.
why I said that the numbers were small.
The numbers are small. No, you're good. That's also known as the Pythagorean triple, right? 3, 4, 5, 6, 8, 10, right? So it's fine if you see it and do that, or you can do the mental math. That's fine. Yeah, perfect. Okay. And then?
And then on the other side, I rewrote it as the cosine of beta squared minus sine of beta squared. Or like I put it on parentheses, like cosine of beta. Or you're running like that.
No, you're fine. I'm just gonna write it so people learn it.
Okay.
But I love that you just wrote it because, I mean, y'all are so smart. You can remember these formulas. I just have so much storage and it's full. So I just have to derive it each time. May God bless you. Remember, if you start with cosine, you have to change it, right? And then whatever's first is first, whatever's second is second. But in this case, that's both betas. So that's why he said he wrote cosine of beta squared minus sine of beta squared, right? Okay, sorry. Now I'm ready.
And then we already found the side lengths, So you can just replace it. So the first one would be -4/5 squared, and -3/5 squared sine.
Good. And this one's -4/5 squared because cosine is adjacent over hypotenuse. So we don't need tangent. We were given sine, which is opposite over hypotenuse, so we have to use adjacent over hypotenuse. Good. Okay?
Then you just got to square them. So it would be 16/25
Good.
minus 9/25. And they have the same denominator, so you can just subtract across the top.
Mhm.
And it's
7/25. Very good. Questions? Any questions? Questions? No. Okay. So you'll see on that one, I'm not giving you more double angle formulas because it's pretty straightforward, right? So the only thing left is called the half angle, and that is a formula. I do want to show you it. I don't know that we'll get to work through examples, but the half angle formula, I want you to just stop for a second. I want you to take a minute, look at the two formulas, compare and contrast them. Okay? So just take a minute.
Yeah, the sine is negative. It's not cosine is positive.
Could you go back to the sun?
Oh, that's right. You need the notes. You need the notes. It's like I gotta watch a video then, bro. I don't know what to tell you.
Well, yeah. Really.
So what were you saying? I'm sorry. He was asking me a question. I was scrolling it. And you were saying what?
So, like when the sine is like you're subtracting and then it's cosine you're adding. That's one thing I see different.
He said the only thing you see is different is when it's sine you're subtracting and when it's cosine you're adding. You agree with that statement? Is it the exact same formula and the only difference is one's a plus, the other's a minus? So, the way I remember it, if it's a half angle, now this doesn't work for the sine, cosine, cosine, sine, cosine, cosine, sine, sine, okay? If it's a half angle formula, just remember, if it's sine, subtract. But otherwise, it's the exact same formula, okay? So if it's sine, you subtract them. That's the only difference. So it's 1 cosine of the angle all divided by 2, okay? And then you either put a plus or a minus, and then you square root it, and then you figure out if it's positive or negative depending on which quadrant, okay? So I'm going to show you that really quickly. Alpha is the angle, okay? So look, it says you must determine if the final answer is positive or negative, and that depends on which quadrant the angle started in, okay? So remember, if you start in quadrant 1, the angle alpha starts in quadrant 1, okay? Think about quadrant 1. A lot of times we talked about that from 0 to pi over 2, right? But another way you could think about it is if it's in quadrant 1, it's between what? 0 and first quadrant, y'all. First quadrant. Let me draw a picture right here. First quadrant. It's between 0 and pi over 2, or in degrees, because y'all like degrees better. 90. So between 0 and 90, okay? So if you have that angle, then alpha is over 2, which means it's going to be 0 divided by 2, but 0 divided by 2 is 0. 90 divided by 2 is 45. So if your angle, that half angle, is between 0 and 45, what quadrant are you in? The first. So if you start in the first quadrant, you're going to end in the first quadrant. What is sine in the first quadrant? Or cosine, rather. What's cosine in the first quadrant? Positive or negative? It's positive. So my answer is going to be positive. You see what I'm saying? If it's sine, sine's in the first quadrant. You half it. You end in the first quadrant. You get positive. Yeah. So that's how you figure out, is it positive or negative? It depends on where you're starting and what you're looking for, okay? All right, so if you start in quadrant 2, what are your degrees between, if I'm in quadrant 2? 90 and 180. So alpha is between 90 and 180. But if I half that, then alpha over 2 is going to be between what and what? 45 and 90. Well, what quadrant is 45 to 90? The first. So guess what? Sine and cosine are both positive, so your answer is going to be Positive, because you're in the first quadrant. Okay? Next one. Quadrant 3. Quadrant 3 goes from 180 to 270. So the angle is between 180 and 270, which means a half angle is going to be between what and what? What's half of 180? 90. What's half of 270? 135. May God bless you. Gracious. May God bless you. Ah!
Sorry.
May God bless you. You're welcome. Okay. What quadrant would have 90 to 135? The second. Now, on this one, you're going to have to think about it because in the second quadrant, they're not both positive, right? So, if you're working with cosine's what in the second quadrant? Negative. So, your answer is going to be negative. If it's sine, it's going to be positive. So, right now, if it's sine, my answer is always going to be positive so far, right? Okay. And then lastly, 270 to what if I'm in the fourth quadrant? 360. It doesn't like when I write 3. Sometimes it just changes it to a line. Oh, it does look like a B. You're right. I'm sorry.
Appreciate it.
Okay, so quadrant 4 is from 270 degrees to 360 degrees, which means if I half that, half of 270, 135, half of 360, 180. What quadrant is that? Second. So look what happens. If you half it, you're always ending up on the top of the unit circle, either in the first quadrant or second. What's sine?
And the second one.
It's either in the first quadrant or second quadrant. So what's the sign when you're up there? Positive. So look, if you're taking the sine of a half angle, is it really plus or minus? No, your answer is always going to be plus. You just learned that. Hopefully you'll remember it. Now, cosine, it depends. If you start in the first quadrant, you're going to end in the first quadrant. Cosine's positive. If you start in the second quadrant and you half it, you're going to end in the first. So cosine's positive, okay? But if you start in either the third or the fourth, when you half that, it puts you up in the second. So your cosine's going to be negative, okay? Any questions so far? No? So with that, yes, you just need to memorize that formula, okay? So write it, hear it, say it, see it. Hopefully you'll learn it, okay? All right, so 1 plus cosine alpha divided by 2, and then you square root and then plus or minus. And if it's sine, subtract, okay? So I'm going to put that right here. Cosine of t over 2. So it's 1, then the cosine of the angle, so cosine of t. It's all over 2, right? You see what I'm doing with that formula? I'm writing the pieces. So 1, then cosine of t, over 2, square root, plus or minus. And now look at what you're starting with. You're starting with cosine. So should that be subtract? It's adding. Okay? And where are we starting? What quadrant? Let me look. Where was I? I'm in quadrant 3. I'm starting in quadrant 3. So when I half it, I'm going to end where? Quadrant 2. Good. So if you're in quadrant 2, what's the cosine in quadrant 2? It's negative. So my answer is going to be negative square root. Does everybody see how I just figured that out? You start in quadrant 3, which means when you half it, you're going to end in 2, which means your answer is going to be negative. Okay? And now just plug in. Super easy. So 1 plus, what was the cosine of t? Let me go back up here to my problem. Cosine is adjacent over hypotenuse. So negative 15 over 17. Everybody see that? I'm just going to plug that in. The negative 15 over 17. And then that's all divided by 2. Now, this is why all semester I've been trying to get you comfortable with fractions, okay? Because when you have 1 plus a negative, that's actually minus, right? I'm going to do a little scratch work over here so that I can get a simplified fraction. So it's 1 minus 15 over 17. Would you agree? Okay. And then what do we want that 1 to be? 17, right? So we're going to multiply this by 17, multiply this by 17. So we get 17 minus 15 over 17,
It's 2.
which is 2 over 17. So now I can replace that whole thing with 2 over 17 divided by 2. See how much easier that is? Work that scratch paper, okay? What do you do when you have a fraction over something else? Keep, change, flip. Keep, change. And what's this 2? 2 over 1. So we got to multiply. 2 times 1 is 2. 17 times 2 is 34. Or you could just see the 2's. 2 over 34 reduces to 1 over 17. Okay? You can still get there if you do 2 divided by 34. Then you divide the top by 2, divide the bottom by 2. You'll get 1 over 17. Okay? Last step. Can you divide square root 1 over 17? No, so I'm going to split it. Square root of 1 divided by square root of 17. Because the square root of 1 is 1 over the square root of 17. And you can leave your answer like that. I don't need you to rationalize, but you can, but you don't need to. Okay? Questions on half angles? No? Everybody good? Okay, great. You're good then. Yep, you can go.